Yeah, let's continue. I think we're entertaining the homologous series in the last clip. To just say homologous series, there are 9 all in all, from alkane up until to ketone. We'll know all of them. It's not a problem for now. And then there are 3 hydrocarbons and 6 derivatives of hydrocarbons out of the 9. Now, the homologous series by definition is just a series of compounds. The homo stuff, I mean they're the same series of compounds with the same functional group. That's the easiest one definition. Or series of compound that can be represented by represented by the same general formula. We'll talk about the general formula for butane. So yes, we'll talk about the general formula of compounds here. Now, yes, the series of compound with the same functional group, or the series of compound with the same general formula. That's the homologous series. Now, we said we have got 3 hydrocarbons and 6 derivatives of hydrocarbon. Let's start with hydrocarbons. As we say, hydrocarbons by definition, they are organic compounds here which consist of only carbon and hydrogen. So now those hydrocarbons, there are only 3. They are called alkanes. You have to know alkenes and also have to know alkynes. Now, what's the difference between the 3? Maybe before we come to these differences, let's go to the so-called, in dealing with this section, we'll be talking about this one. We'll come back to that one. All alkanes end up with this, what we call a suffix. All alkanes end up with an ane, meaning that if you see propane, butane, methane, mean that is an alkane. And all alkenes end up with an ene, and all alkynes end up with ine, this one. Now, if you go back to our presentation, whereby now we're talking about the single bonds, double bond, and the triple bond. That's where this section is. So alkanes will be the hydrocarbons that consist of single bonds between carbon atoms. Now, single bonds between carbon atoms. That is this one. So single bonds, only single bonds. Let me talk about the word only. Only single bonds between carbon atom, between C atoms. And because of these single bonds between carbon atoms, or having no multiple bonds, many ways to kill a cat, someone can say in the example, no multiple bonds. So compounds with no multiple bonds between carbon atoms, yes, they are alkanes. And as a result, these alkanes will be now said to be saturated hydrocarbons. Why are they saturated? Because they have got only single bonds between carbon atoms, or because they have got no multiple bonds between carbon atoms. That is the definition in a way of saturated hydrocarbons, or the reason for thereafter. Alkenes will be having double bond between carbon atoms. Now, as this one of double bond between carbon atoms, where you see double bond in a compound, know that compound between two carbon atoms, then that one is an alkene. It will end up with an ene. Then this one has got a double bonds between in this case carbon atom, C atoms. Remember, in this case only one double bond. We used to entertain dienes. We are no longer doing dienes in our scope, so we do only one double bond between carbon atoms in a compound. And hence these ones, or they have, you can, if you don't want to say, you can say have multiple bonds between carbon atoms. Multiple bonds between carbon atoms. Yes, that is another way. Or this one now, as a result of these two, then they are going to be called unsaturated hydrocarbons. These are reactive, whereas these ones are not reactive. Unsaturated U. Coming to the third type of hydrocarbon, which is an alkyne. All alkynes end up with YNE. Why? Because they've got triple bonds between carbon atoms. If you see triple bond, it's an alkyne. And then again, this, we say they've got triple bonds between carbon atoms, between C atoms. If they say, why is this an alkyne? Because of this. Or they do have also multiple bonds. Same thing, have multiple bonds between carbon atoms. And that when we talk about unsaturated, is the now an organic compound with multiple bonds between carbon atoms, or an organic compound with double or triple bond between carbon atoms. So this one also will be unsaturated. In terms of the degree, we can say this is unsaturated, whereas this is highly unsaturated. That is the case. Now, before we come to the examples of these hydrocarbons, let's entertain the issue of prefixes. We're talking about the suffix. Now let's entertain the prefixes so that you are not going to be lost here. Prefixes. Don't mind my English in this one. Fine. 1 carbon, 2 carbon, 3 carbon, 4 carbon, and then 5 carbon, 6 carbon, 7 carbon, 8 carbon. If a compound has got only 1 carbon, then in this section it will start with the meth. Then if it's an alkane, it will be methane. Carbon with the compound with 2 carbon atoms will be eth. If it's an alkane, it's ethane. Therefore, compound with 3 carbon atoms will start with prop. If it's an alkene, it will be propene. And the one with start with 4 carbon, with has got 4 carbon atoms, will be bute. If it's an alkane, it's butane. Now 5 carbon atoms is pent, and then which will be your pentanol, pentane, pentene, then 6 hex, and then 7 hept, 8 oct. So our guideline says maximum of 8 carbon atoms in this case. Now we are ending up with oct. We talk about octane, therefore it's an alkane with 8 carbon atoms. So now it will be easier now to know in terms of let's say alkanes. Let's start with alkanes. All alkanes, remember, they start with they finish with ane. Now the first member of alkane will be your methane. 1 carbon atom, therefore this is methane, CC. Then this will be the structure. Remember, we said we have got different types of structure. This will be called structural formula. In a structural formula, we show all the bonds. Remember in our previous presentation. Now this is the UPEC name. Yes. And then this is the structural formula. We are running short of 2. There we have got the CH4, which can be condensed structural formula. Condensed structural formula. In this case, also CH4 can be a molecular formula. It will differ when we go to many carbons formula. Quickly we can go as well as, that is your alkane, the methane number 1. The structural formula will be showing all the bonds around carbon here, and this is the structural formula. Methane is the UPEC name, CH4 becomes the condensed, CH4 again molecular. But now it becomes clearer when we move up the ladder. Ethane, alkane number 2, will have 2 carbon atoms. Can you see? Eth, 2 carbon atoms, therefore that's why it's ethane. The structural formula will be 1, 2, and then all the bonds. This will be the structural formula. The condensed structural formula, which is number 2, this is the UPEC name, remember the UPEC name, that is ethane. The structural formula, this is the case. Fine, this is called structural formula. And then the condensed will be CH3. This is condensed structural formula. Then the molecular formula, which shows just the ratio of atoms in the compound, will be now C2H6. This is the molecular formula. I hope you now get the gist of structural formula, all the bonds. Condensed, this one no bonds or some bonds can be shown, whereas the molecular is just a ratio of atoms in that compound. I think it's clearer now, so we'll move on again up the ladder. For now, just quietly deal with propane, see whether you understand, and also draw the structural formula, the condensed structural formula, and the molecular formula of propane. And then we'll deal with the butane. You can just try also butane. So but 4 carbon atoms, prop 3 carbon atoms. Draw this one in terms of structural formula, condensed structural formula, the molecular formula. Then we'll unpack it more in the next clip.